Okay, this is a great question. We've embedded phosphorus 32 into sodium phosphate, and we're trying to figure out how much phosphorus 32 is left. Now, all the phosphorus uses phosphorus 32, but we have 175 milligrams of the sodium phosphate. So we got to go back to our early days of chemistry to figure out, well, how many of these milligrams are from phosphorus? And so we're going to go 0.175 grams. We're going to add up sodium's 22.99, phosphorus 32, oxygen 16. There's 4 of those, 3 sodium, so we have 164.94 grams per 1 mole. And then we're going to say for every 1 mole, there is 1 mole of phosphorus. And every 1 mole of phosphorus has 32 grams. And so we are going to do 0.175 divided by 164 and times 32. And if we get it back to milligrams, we get 33.95 milligrams of phosphorus 32. Now, into our nuclear time question, we're trying to figure out how much is remaining. We know the half-life, so when we know half-life, we got to first solve for K because we need K in our equation. So we got K equals 0.93 over half-life. We rearrange that equation. 693 divided by, my half-life is 14.3 days. So I'm going to do 0.693 over 14.3. And I get 0.693 divided by 14.3, 0.0485 days minus 1. Now I'm going to use my equation. NT equals NO e to the negative KT. I got K, my time is 42.9. So I see that I start with 34 milligrams. I've done 14, 28, about 3 half-lives here. And so I should be down to 33, about 4.24 grams. Or so let's solve, and we see our original was 33.95 times e to the negative 0.0485 times 42.9. And we got, so negative 0.0485 times 42.9. We're going to do e to that number. You get 0.125 times 33.95, so 4.24. And it's pretty much exactly 3 half-lives, so I could have probably estimated my way through it. May not be the case for you if that 42.9 is different. But so being able to use the equation is good, but being able to estimate how much time is good as well. And then we can flip this around. Maybe we have to solve for original concentration, or maybe we have to solve for T. Remember, we can do T equals negative 1 over K times the natural log of NT over N0. And so different ways to solve for it. In this case, we're looking for how much phosphorus is left in this initial part is a little bit tricky. Let's plug it in. 4.24. There we go.